using this GarageWorks CNC for some joinery work. And we've made a small vertical hold down table for the CNC, which really wasn't designed to hold something like this. The way this was designed is the spoil board here would come out and sit right on the ledge at this point. And even though it looks like there's enough hold over here, enough hangover to get out to the side here to clamp something on, it really doesn't. Based on where this comes and what this hits here, we only have about an inch or so, maybe an inch and a half over the side, which is really not enough to work with. And especially if you have any kind of hold down mechanism, that inch or so is just too tight. So I gave some thought to this, and the way this is constructed, we've got our beams kind of going through the center here, but we do have the ability to just slide this board, the spoil board, back, which gives us a nice space up front here to work with. For the jig here, it kind of is what it looks like. It's pretty straightforward, pretty simple. We've got a Matchfit hold down system here, and I've got a few other pieces down on the floor that I made a while back, and we're probably going to turn another part of that board into a sled for the table saw. But for this little jig right here, we just CNC cut this 3/4 inch plywood out. You can see the overcut here, so we went a little bit deeper, but that's what a spoil board is for. So we've got our piece here, and then I split a 2x4 down. So we've got two sections here. There's one here, and there's one underneath. And the board here, this MDF Matchfit clamp down system, is just glued and screwed onto here. We've got a nice, good 90-degree angle on the front on this side, and a hold down system here. These Matchfit clamps and the system in general is so versatile and so customizable. There's all kinds of ways to use this for things like this, as well as router tables and table saws and band saws, and just having a clamp down mechanism for your bench. So really, really cool. All you got to do is buy the bit, and you can cut whatever you need to cut. So this is our jig here, and we're going to do some joinery tests. I'm an old school Mach 3 guy. I've got videos going back the better part of a decade for different CNCs, home-built ones, purchased ones, modified ones. And this one I picked up last summer that wasn't quite complete. The gentleman was just done working on it. So I've been dialing this in for different projects and making it kind of my own. So this is the first try with this. This is just a basic mortise and tenons, sort of. We're kind of doing circles here to see how this joint works. This is going to be the tenon part, so we'll have our tenons here, and then that piece will be for the mortises for the other side of it. So we've got this zeroed up, and if we just move this out of the way here, and you can see how this moves back on our screen there, which just follows the track of where this is. We know where our 0 is because we can go back to Z on our screen, and then our router will go back to our starting point. So let's fire this up and see what we got. For our mortise and tenon test piece that we're working on here with the new jig, this is just a simple design I drew up in Vectric. So we're just in Cut 2D. I've got Cut 2D Pro here, so we've got some more space for the larger CNC. But Cut 2D without the Pro, just the basic one, would work fine. And any software that can do pockets can work for this. It's just a little bit different setup. So this is the end of our piece here that we're working on for our practice joint. And I made this a little bit larger for our outside perimeter here because I wanted a little bit more adjustment on the fly. And I'm still setting up my registration marks, so we're still working on that. But as far as this goes, and this is not a full tutorial on how to do this, there are some really good Vectric tutorials out there, so I'm not going to try to replicate those. But for this, we're just making 2 files. And if we click that, and then go over to Pocket here, we're cutting down 3/4 of an inch. We're using an eighth of an inch end mill here. Then we go to Calculate, and we can kind of see our design at this point. And if we go to Reset Preview and preview all toolpaths, we can see our tenons at this point. If we go back to the 2D view And if we just want to have our mortises, our holes cut out, we'll go there, reset preview, close this. These will also be pockets, and then we can calculate this. And then this shows the spiral cut for the end mill. Reset preview, preview all toolpaths. Actually, this is the flop because we've got the other here. So if we take this one out, just go to this one, reset preview, and preview all toolpaths. Then this shows the inside for our mortise joint. Then we save these files, go over here, and then this would just be saved to, in our case, a USB drive, and then we walk it over to our very old laptop and make our cuts. That's the first look of our first test cuts with this vertical hold down jig here. This was drawn up real quickly last night in Vectric Cut 2D Pro I guess, but any CNC program that you can do pockets would work with this. I've still got some reference marks to dial in here and get this really tuned in, but these are looking pretty clean. So obviously without the dust shoe, so we can see the process. Next thing is to lock that piece down and cut our mortises. And we've got our second piece clamped down. We're going to cut this without the dust shoe, so this will be messy as per that one. But I want to see how this kind of lines up and show how this lines up. So let's get cutting on our mortises. Had to do a little bit of dialing in here So the first run here, which was pretty much on the line, was a little bit too tight based on some measurements. I haven't physically put this on here yet. So we did a couple extra runs here, 0.02 of an inch and 0.01 for a negative allowance here to go over that line that goes around the outside. So let's take this off, put this on here, and see where we are. This is just dialing in and testing. If we were batch cutting for a big project, we could set up references and marks and just let the machine go at it. But for now, we're just kind of dialing this in. That's our negative 0.02 offset right there. And we do have a little room for glue if we were going to do this, but that's a little bit looser than I'd want it to be. You can see there's some play there. So probably the best fit is between these two, between negative 0.01 and negative 0.02, somewhere in the middle there. But let's line these up over this. I'm going to give it some hammer taps and see if we can get that on there. That's a pretty nice joint. For the offset, negative 0.01 fit really, really well in there. And these were pieces of wood that were just off the junk pile. These were not planed or jointed or squared or anything like that. So it's kind of cool to see that these fit this well in here. We do have a little cupping on the inside here because, again, these boards were not prepared for anything like this. This was just first testing. But this jig works great, holds really, really well. CNC seems to be pretty consistent. And these are looking really nice. So we've got lots of options with this. For boxes, for benches, for any kind of joint. We could have hangovers on the side here. All kinds of neat possibilities with this. But those look really, really nice. Just hit it for about 20 seconds with the sander, and those are looking really, really good. When I designed these up, I designed them to be 3/4 of an inch, so they went through the whole run there. But this works really, really well. Awesome jig. Very cool. Thanks very much for taking a look.